Welcome everyone to our first MIDRC seminar back from summer break in full force with an excellent speaker. And before I introduce her, I'd like to remind everybody that there will be a live Q&A session at the end. So please don't be shy and put your questions in the Q&A box during this seminar. So our speaker today is Dr. Kyle Myers. Most of you know her as a research scientist and manager in the FDA Center for Devices and Radiological Health, where she served for over 30 years. She co-authored Foundations of Image Science, winner of the first biennial J.W. Goodman Book Writing Award from OSA and SPIE. Kyle is a fellow of AAPM, AMB, Optica, SPIE, and a member of the National Academy of Engineering. She received her PhD in optical sciences from the University of Arizona, and she now works as an independent research collaborator and consultant to medtech companies. So without much further ado, here's Dr. Kyle Myers.
I'm trying to start my video. There we go. Thank you, Karen. Thank you, everyone, for attending today. It's my great pleasure to speak to you about the topic of how MIDRC can assist you in the evaluation of your and translation of your algorithm. Sorry, I was trying to get rid of the controls. So let me start by, before I answer that question for you, providing you with my financial disclosures. I am funded in part by MIDRC. And as Karen said, I do accept some funding from investigators who are seeking U.S. market authorization for medical imaging devices. So here's an outline for this presentation. It's been a summer break from these monthly seminars, and maybe there are some of you in this audience who have not had the opportunity to get to know MIDRC prior to now. So for those of you who are MIDRC followers, I'd like to give some interesting and exciting, I think, updates and an overview for those of you who are less familiar. Then I'm going to talk about some public resources from MIDRC that are positioned to facilitate the evaluation and translation of your algorithms with MIDRC support. And the last third of my presentation will particularly focus on the sequestered data that has been set aside by MIDRC to support the algorithm evaluation for your tools. So let's get started. So MIDRC as an imaging and data resource center was established in August of 2020. It's a partnership between the three important professional societies in the medical imaging domain: the American Association of Physicists in Medicine, the American College of Radiology, and the Radiological Society of North America. MIDRC has support from NIBIB and ARPA-H and is hosted at the University of Chicago. We are now a collaboration of about 20 institutions and more than 100 investigators from academia, community practices, FDA, and others. And you can see on this map that it's quite diverse in terms of the institutions that are involved. Now, when MIDRC was established, there were two scientific aims that were articulated. The first was the development of an open, scalable, curated discovery data commons. And the second was the development of machine intelligence computational capabilities in terms of developing and supporting the development of clinically relevant algorithms and software tools. And I think you're going to see evidence of that today. So here's an update that I think is just really stunning since the last time we talked about this last spring. MIDRC has now, as we have worked to establish this resource for AI and medical imaging, ingested more than 500,000 imaging studies, 500,000. We've released already 177,000 plus imaging studies to the public, with data coming from 22 states. That constitutes imaging and data from over 73,000 unique patients. Truly, this is a resource intended to support the medical imaging AI/ML ecosystem through this development and sharing of high-quality, representative, trustworthy data. But on top of that, we are working together collaboratively to develop and promote standards, sharing, transparency, and best practices, and lower barriers to the access of data and the software that I'll be in part describing today. And together, taken together, we see our role as being that of accelerators for the translation of AI ML, especially in medical imaging. But I think you'll see from the tools I'm talking about that it's bigger than that. And we are going to be talking at the end of my talk about how one particular approach to accelerating translation is the use of the sequestered data set for algorithm evaluation. So MIDRC by the numbers I just presented to you. Here's MIDRC by the pipeline. MIDRC includes a sequestered data commons. So MIDRC is ingested into, the data is ingested into MIDRC. It undergoes a data quality and harmonization process, and you can see that process is being undergone by a number of imaging studies that will soon be available in the public repository, which is reflected here in the amount of data that has already been released, available for you to download today at data.midrc.org. In addition, MIDRC is the only medical imaging data repository data commons to have a sequestered commons, a locked commons that has been established to allow for fair comparisons of algorithms while maintaining and ensuring that the data are diverse and representative of the larger data commons in order to expedite translation through regulatory to clinical practice. So that will be what we come back to later in this presentation. Before we get there, I wanted to first present to you some other public resources from MIDRC that are intended to support the evaluation and translation of your algorithms. And those resources include software and tools, data, publications, presentations, and seminars. The first tool that I want to bring to your attention is that of a MIDRC de-identifier of clinical text. Now, we all know that we're moving into a really important new regime, new world in which we're talking about very large data sets, not tens, hundreds, thousands, 10,000s, but literally hundreds of thousands of imaging studies, which of course have associated with them radiology reports. And we really need to move beyond the requirement for human effort to label that data and to de-identify it if we're to be able to rapidly harness large data sets for AI development and evaluation. So MIDRC has developed an automated de-identification tool for radiology reports, pulling out data in order to protect health information, but replacing it, not just scrubbing it, but replacing it with realistic surrogates. And I'm going to show you on the next slide how we've evaluated this tool and shown how effective it works. You can see an example here of an original report and the output of the de-identification software. Most of my slides will also have a gray box like this one to give you the opportunity to find this tool readily, identifying the MIDRC tool name, where you can find it on our GitHub link, or where else you might find it on a web-facing link, and a companion publication. So MIDRC evaluated this model against both automated tools in the literature as well as human labelers using the informatics for integrating information to the bedside data set. And you can see the accuracy of the MIDRC medical text de-identification algorithm shown here. The MIDRC algorithm is the one that pops out in the red histogram bars. Here we have on the left MIDRC's performance versus published algorithms in the literature. And on the right, against cloud algorithms, those from Google, Amazon, and Microsoft, and you can see we do quite well. So my point here is that, well, this is a tool that is being used today to support the MIDRC enterprise. It can be generalized to your purpose, even if you are using data other than that that is being collected and shared by MIDRC. All right, the next tool that I wanted to present to you for your consideration and use in your work is the MIDRC data harmonization process through LOINC mapping that allows for cohorts to be built for particular AI development and evaluation needs. So I'm sure many of you have had this experience of looking for data that meets your development goals, and across institutions, the input study descriptions can vary widely. So here we have a set of input study descriptions representative of the data that has been ingested in MIDRC. And you can see that the data table here has a problem, a long tail distribution problem, where the number of rows here is close to 1,400. Now, through the development of this LOINC mapping table, we can take, for example, studies that really all represent the same thing, a CT chest exam without contrast, named differently across different institutions, and harmonize the naming of those studies, pull them all together to constitute one row in the study descriptors in the MIDRC data to make this list of study descriptions far more workable, far more manageable, with a concomitant reduction in the number of descriptions of about 95%. Here again, you can find the MIDRC tool name, and you can get access to this software here. It's quite general. It could be used for other purposes. So I told you how large the data set is that has been shared. I told you how large the data set is that's been ingested. Let's talk about the data demographics. So here's a current snapshot of the MIDRC Open Data Commons, representing more than 70,000 unique patients. Open, I should correct myself and say pre-published. They're data that we intend to make open, but we hold back for a little bit to support the MIDRC challenge work that we do in order to help the community understand the state of the art for different AI development tasks. Nevertheless, you can see in this graph, we are able to plot the data distribution across different data elements. Here I have, age at index, sex, race, ethnicity, race and ethnicity, COVID-19 positive. So we're able to make sure that we're following the data according to these distributions. We're still in the interest of collecting data. I think that we will be saying that on into the future. So if you're interested in contributing to data, please note the link here. Having pie charts is lovely. What you'd really like to do, though, is take that a couple of steps further. The next step that you'd like to take is to track the data diversity over time. And that's what you see in this graph on the left. One particular data element is race and ethnicity. So this is essentially taking that pie chart and turning it into a temporal graph. The imaging data in the pipeline that comes into MIDRC after the data distribution or contribution agreements have been put into place allows for us to pull in new data and assess how it changes these kinds of diversity calculations. And you might say, well, that's nice too, that you're right, that is a step up. We're following this over time. But what you really want to do is to evaluate the representativeness of the data in MIDRC to the data that is the target population for your device. How might you do that? Well, we have an answer for you, and that's the diversity calculator tool that has been developed by MIDRC investigators and is represented here. So I'm introducing here a particular figure of merit called the Jensen-Shannon distance. Some people refer to it as the Jensen-Shannon divergence. So I know this is hard to see this graph. I just want you to get the gestalt, which is instead of plotting as we did on the left, data percentages over time, here on the right, over time, what we're plotting is a statistical similarity metric between two statistical populations. One is one could be the MIDRC data set, the open data set, and one could be, for example, as shown here, US Census data, or another one might be CDC COVID positive case counts. This is the particular use case presented here, but the tool is more general than that. So if you are developing an algorithm for a particular use and a particular target population, you can use this tool to evaluate both your training and your testing data sets with respect to their similarity to the population that you intend to have your device work for, to have more confidence that your device will generalize to that population. So more representativeness means lower values on this curve. One means no similarity. Low means no, because remember, this is a distance or a divergence is the way to think about. So high distance means low statistical similarity. Here again, it's called the MIDRC Diversity Tool or MIDRC Diversity Calculator. You can find the web link, the software, and even a demonstration video. Now, that was one particular data element being plotted over time. If you were interested in looking at multiple data elements, there are other approaches to doing that. This is just one using a spider web type of plot. There are others. We just wanted to make sure that it was clear that we understood that and that we're looking at ways of doing that. And if this is a topic that's of central interest to you, I encourage you to check out the MIDRC Diversity Calculator seminar that was given just last spring by Robert Tomek and Heather Whitney. Here's another tool that is finding a fair amount of use now within MIDRC and externally, and that is the metric tree that we developed. This is a tool for walking you through a set of questions around what sort of an algorithm you're intending to develop for what kind of task. And depending on whether or not your task is classification versus segmentation versus estimation, this will walk you through the various sub elements of that decision process around the development pipeline for your algorithm and support you in choosing an appropriate figure of merit, pointing you to literature, pointing you to software tools that might help in your evaluation. And again, here is the link, here's the publication to that tool. More recently, we have turned our attention to the specific application of oncology, and we are building now a metric tree for cancer with particular oncology medical image analysis tasks. And you'll find that on the website as well. And we're quite gratified that this has been incorporated into FDA's catalog of regulatory science tools. Here's another tool that is quite useful to those of you that are in the development arena and are interested in ensuring that you are aware of the ways in which bias might enter into your development process, from the steps of data collection to model development, model exploration, model deployment, etc. And this, again, is a bias awareness and bias mitigator tool that allows for identifying and mitigating, not just knowing what they are, but what you can do to mitigate potential biases in that roadmap. So you can find that tool on our website and in a companion publication. So it also functionally operates like a tree in the way that the decision tree does for helping you find metrics. It's very simple and easy to use. You pick a particular bias that you're interested in learning more about. Perhaps that would be population bias. It tells you what that bias is. It tells you why it's important, where you might find some real-world examples, and how you might mitigate it, and various places along the development pipeline where you might see this enter into the process. Here again, this is something that is we intend to be useful far beyond the MIDRC users of MIDRC data. It's general. So now let's turn our attention to the MIDRC sequestered data and the algorithm evaluation service that we're building. So as I said before, MIDRC, as far as I know, is the only imaging data commons that features a sequestered test set. About 20% of the data are sequestered, and a very small number of people have access to that data. Our intention in making it in that way is for it to act as a large test set from which task-based samples can be drawn, and I'll come back and explain what that means more precisely. By being able to leverage this test set for evaluation of algorithms, we intend to accelerate the translation of AI/ML algorithms, facilitating real-world performance evaluation of AI/ML algorithms on representative data. So how do we know that the data is representative? Well, I'm going to give you two rationales for that. One is the particular approach that we're taking to sequestering the data, and that is through what you see here, an approach that we refer to as stratified sampling. It's a way of splitting data that is incoming to MIDRC between the open and the sequestered data set into sub-buckets that are split at every level to allow for ensuring that the open and the sequestered data sets are balanced. Okay, so data might come in from different sites. For a particular site, it's split by modality, by disease, by age, race, sex at birth, ethnicity, and then within each of those buckets, 80% goes to open and 20% goes to sequestered. Now, this is what we are doing in MIDRC. You can do this too for entirely different application areas where you know what is most important for you in terms of ensuring that the data that you use to develop and validate your algorithm are similar in the right way to the data that is used for testing. So we have put out a generalized version of this code in order for this to be modified for general use. The other thing that we can do, of course, is to put to work our Jensen-Shannon divergence calculator to demonstrate that the open and the sequestered data are similar. So here are just some examples showing that all of the data across age up on top, here's age on top, all data on the left. The open pie and the sequestered data pie show the similarity of those distributions. Similar for race, all data here, open and sequestered. And it's, behind the scenes for calculating the similarity between the data sets. And because we have been doing this since the beginning when data was coming in August of 2021, it's not like we're having to play catch up and, overfill the sequestered data with data elements that we didn't do a good job of pulling into sequestered space in August of 2021. We've been doing the sequential sampling from the start. So, and evaluating it as we go on an ongoing basis. So I get the question all the time, if you want to know, I want to know what kinds of tasks the sequestered data might support. What kinds of evaluations might you be able to do? My answer back is to say, well, look at the open data. That tells you, without telling you case-by-case line data, what's in the sequestered data. If the data in the open commons would be suitable for developing your algorithm, then I have data in the sequestered commons that reflects a similar set of populations for that. So how might we use the sequestered data for performance assessment? So our envisioning of this looks like this. Somebody, a developer of an algorithm, finalizes their algorithm and surmises that it is ready for third party for independent evaluation for a particular task. So in this case, the task might be classification. How well does my algorithm separate patients in these two groups? The submitter would submit that algorithm to MIDRC for testing, making use of the locked sequestered commons. Based on the intended use, the target population, the expected claim, MIDRC pulls particular images and patients from the sequestered commons, performs a performance assessment, and provides results to the developer. Upon request, MIDRC would be willing to provide reports as well to the FDA, likely longer reports. That's what I'm trying to show here with these two pages versus one. Longer because, as we'll talk about a little bit more in this presentation, it's so important for MIDRC to ensure the integrity of this test set. So in order to not have repeated uses of the test set result in learning of the test set, some of the information that might be sent to FDA would not be provided to the developer. And, really what we're talking about is case by case results might not be presented. So operationally, what does this look like? Somebody comes to MIDRC, and if they have a task, for example, a classification task looking to determine whether or not an algorithm intended to differentiate COVID positive from COVID negative patients making use of chest x-rays. That represents a set of two distributions of patients, those with and without COVID. That would be one sampling of the data underlying the sequestered commons that we might use as our starting place for drawing samples for testing. A different requester might be interested in evaluating an algorithm developed for a different task, for example, estimating COVID severity. And in this case, suppose it was from all CT data for that specific task and population. So we might imagine a distribution of patients all deemed to have a set of different estimated disease severity ratings. So let's just use this one as an example up on top. If it was this example with the classification problem, the testing involves drawing a task-based sample from the relevant distributions in the sequestered commons. So we're pulling data from these distributions, not these, right? And if the algorithm developer receives those reports, goes back to the drawing board and makes some adjustments to their algorithm, comes back sometime down in the future and wants to test again, now we pull, I hope you saw that, a different set of cases from that same test set. Understanding that it was the same intended population. And we can keep doing that over time as algorithms are developed and improved. Code for doing this is available, again, on the MIDRC website. You may have a different problem that you're working on with a different set of data that you have set aside for your evaluation purposes internally. And this software can be used to allow you to do this kind of task-based sampling. So how do we preserve the integrity of that sequestered commons when we're talking about people making use of the data repeatedly? Well, there are a number of guardrails that need to be put in place. The first is that the sequestered set in its entirety is not used for any one test. Second, it's understood on top of that then that the size of the selected test set is going to be limited by the availability of the data in the sequestered commons and the similarity between the specific population that is intended to be the target for the algorithm and the available data in our data set. We also intend to provide performance estimates with a confidence interval, a little bit of jitter. You know, the performance assessment is somewhere in this small range to further reduce the potential of training to the test. And finally, because the MIDRC dataset continues to grow, that offers another way in which we limit the risk of learning the test set. Nevertheless, we understand that this is a research problem for our community that is not fully solved. There isn't a closed form solution that says, you know, for my problem, how many times can I use your sequestered data set for repeated testing? I want to emphasize two things. We understand that's a research problem, and we want to also make sure people are clear that this is not a development data set that is going to be used in that kind of way. It truly is intended to be used infrequently and for third-party evaluation. And we're working on that question of how often can somebody go back to the well to make use of the test set that we have sequestered. And this is a publication that came from an SPIA medical imaging publication just in 2024, looking at a construct called the load factor for minimizing algorithm performance overestimates by using too much of the data and allowing for test set learning in doing so. So there's clearly some sort of a sweet spot that puts together how many times you pull data, how big the test subset size is, you know, a large subset size that reflects almost all of the data surely brings down the standard error of the agency, but at the expense of revealing more about the sequestered data than operating down here. And some place in between will be the acceptable load factor. So stay tuned as that research progresses. Our workflow, again, will look something like this, as developed by a working group we've established in MIDRC that we're referring to as the Validation and Regulatory Working Group, or VRWG. Company finalizes the algorithm, makes a request for testing to MIDRC. MIDRC, if they accept the algorithm evaluation request, allows for the company to put the AI algorithm into a container and submit that to MIDRC along with their corresponding claim, clinical question, and intended population. MIDRC makes use of the task-based sampling code to pull cases from the sequestered data commons, evaluate the algorithm on those appropriate cases, and pass a summary report back to the company upon request, and only when this is deemed desirable by the company does a report get prepared and submitted on behalf of the company, or given to the company to be able to be submitted to FDA on behalf of MIDRC. MIDRC was designed to facilitate translation. From the beginning of establishing the data pipeline and pulling data into the sequestered commons, it was our intention to envision a world in which we would have the resources to do this. And we understand that public data sets, as well as sponsors' internal testing data sets, can and are used all the time in device submissions. But it's a reality that the use of such data can raise questions during device review. The data might not meet standards for regulatory use for a variety of reasons. Furthermore, it leaves it to the company to demonstrate integrity around ensuring that the testing process was wholly independent and separate from the development process. In the case of using MIDRC data, MIDRC is vetting data quality and diversity. The fact that the data have been sequestered ensures the integrity of the test results. And MIDRC is working hard with our industry partners to ensure that the data and the testing methods meet regulatory needs. We want to accelerate device innovation, which is a core element of FDA's mission. And we want to speed device review through confidence in our data and our evaluation process. So as I said, we have industry participation in the MIDRC Validation and Regulatory Working Group because they see the value of the high quality and diversity of our data. They see the value of the integrity of the test results and the potential for speeding the device review process. They are informing our priorities regarding what data within the sequestered commons we annotate and truth first, to allow for us to anticipate use cases based on their own internal development efforts and practices. They are co-developing with us materials and methods for testing, request for testing, and what kind of reporting they would want to see that might be different from what would be given to FDA. They also, of course, have access to expertise on those within MIDRC's community of investigators who have developed the kinds of tools that would be also supportive to their enterprise, like the metric tree, the diversity calculator, and the software. So this is my last slide. Thank you for your attention. If you want to learn more, MIDRC has these monthly seminars. So if you've came to this as your first one, we invite you to come on a regular basis. We hold them the third Tuesday of every month. We host town hall meetings and send out current newsletters. Check out our YouTube channel for recordings of past events and subscribe to our newsletter. If you want to make use of MIDRC resources, and I only had time to tell you about, less than 10 of them, there are many more on the GitHub websites, our publications, our data, and a very important new effort of ours is to move to being able to index data so that we are able to work with sites that are not as willing to send data to a central MIDRC repository, but are willing to work with us to index data that is distributed. And finally, if you want MIDRC to evaluate your AI/ML algorithm using our sequestered data, we're accepting pilot participants. If you want to get involved in the Validation and Regulatory Working Group, please contact me, and I look forward to speaking with you further about these opportunities. So with that, let's open it up for questions.
All right, thank you very much. That was very informative. And even though I'm involved with MIDRC every day, I learned a couple of new things. So thank you for that. Let's go to the questions. There are 2 questions so far. So please add more questions. So the first question is, I would like to ask if there's any textual data, such as clinical notes, included in the MIDRC data set.
Well, the answer is yes. The data come in with some information, but that's not information that's being shared currently in the open set, right, Karen? We can talk about. I mean, it's easy to see what is in the open data set today and what kinds of information about the studies and the various other attributes.
Correct. It's not, the answer would be not yet. We're working on ingesting radiology reports and de-identifying them. But I would also like to emphasize that MIDRC does also work on interoperability with non-imaging data commons, such as N3C, so that if you have patients that have data in both these repositories, you can link them. At least, it's an ongoing work. So that'll be super exciting in the future, where we can have multiple data sources and combine them. Okay, so the next question is, what if the algorithm needs to be tested at the acquisition level? For example, AI-powered guiding system. Can MIDRC help with that too?
So we may not have the data per se for that, correct? But what MIDRC is in the process of doing is essentially setting up a regulatory advising or consulting service that would allow, for example, making use of the metric tree to work with a sponsor for a device like that around how you might evaluate it, what might be some of the study designs using the metric tree, using the diversity calculator. So while we may not have the data in hand, I think that there are some ways in which the expertise, and in particular the tools that we've developed, could be leveraged. And so it would be quite of interest, I think, to talk further about how we might support something like that.
Okay, next question is, are there any restrictions on use of non-sequestered data by industry users for AI training, such as licensing fees, IP attribution, evidence, publication, et cetera, et cetera?
None. We just look for, acknowledgement of the use of our resources. They're out there for your use. We do have some sites that have contributed data that were, not as comfortable with commercial use of their data for applications, and so that data is part of the sequestered.
Right. So there is a data use agreement. Yeah, we have a data use agreement for, say, the more academic researchers, and a separate data use agreement for industry. So all the information you'd be interested in, you can find there. And also on the website, it'll say how to cite properly, acknowledge MIDRC use of the data or tools. Okay,
Yep.
Next question is, are minimum data models for applications publicly available, or ways to check a research study is in compliance and interoperable for analysis? For example, the LOINC mapping tool.
I thought the question was going in one direction, and that was more around recommendations that might come from publications in AAPM. But when you moved into LOINC, I'm not sure how to answer that. Maybe if somebody wanted to be brave and open their microphone and we could talk it through a little bit better, or.
I don't think participants can open their microphone.
Okay.
Maybe I don't understand the question quite, the details of it either. So maybe you can rephrase your question.
It is the case that I used the word standards early on in my presentation, that we're looking to, support standards and best practices. But, you know, we're an organization that works under the umbrella of AAPM, RSNA, and ACR, and we work with them on, you know, publications and statements from those organizations around best practices, around data requirements, and, you know, approaches to evaluating algorithms. So we don't do that kind of work on our own.
Okay, so here's another question about the commercial data. For commercial data use agreements, is it based on licensing the data for a fee, royalties, or other methods?
We are not right now. You know, I can't speak to how that might change some years down the road, but it is not in the near term that MIDRC is charging for use of the data. But we have been generously funded by our government agencies to support this enterprise, both to, you know, answer the use case that was so important in the time of COVID, and to serve as a demonstration project for showing what we can do as a community more broadly. And that is why we are now opening and moving into the world of oncology. So there are no licensing requirements or fees. The data is there. We had almost 500 downloads of the entire data set in the month of August alone.
Mm-hmm. Correct.
And
so
it
this
is
for the open
large
data
set. It is
Yeah.
open data.
The open data is
Terabytes of
freely
data.
available. Mm-hmm. The sequestered data set obviously is a different story, completely separate, for which you would have to pay a fee. Okay, so now there's a clarification about the previous question. So the question is like, how do users know a trove of DICOM fields will be useful for the LOINC map tool so it will do a good job?
So I'm not an expert at that. Maybe Emily, you could put in the chat the, you know, the contact information or way to do that, to get in touch with Paul Kinahan or others on that project who would be able to answer that question, because I'm speaking for many investigators here.
Right. Yeah. So I think that the question would be better answered by the LOINC mapping experts, which I don't belong to that group either. So I don't want to butcher an answer. Okay, so that was the end of the questions. Oh, no, that was not the end. I'm sorry. So beside COVID-19 images, what other data are or will be available? Is there any timeline to releasing them?
We don't have a timeline, but we are absolutely pulling in data from other for other purposes. That is a work that is underway, and I know that there will be a seminar that will be coming this fall where we can put more meat on those bones. So that is what we have been funded to do. Because of the successes that we're standing on, ARPA-H has provided funding for us to move into oncology, and that is moving fast. So I don't have timelines, but it's happening.
Yeah, it's happening. We're going to focus on cancer imaging, as well as some long COVID, and we already have long COVID data sets coming in, such as brain or heart imaging. So we're definitely pivoting away from the acute COVID use case. Okay, now this was the last question. So I would like to thank the audience for the questions, and I would like to thank our speaker for an excellent talk. And I would like to see everyone again in a month. So
thank you all.
With that, thanks and goodbye.